limit x tends to infinity of 2 times x, tangent of 1 divided by 3 times x. So we have x tends to infinity. This one of the type infinity times tangent. Tangent when this one tends to infinity, this 3x tends to infinity. 1 divided by that tends to 0. Tangent of 0, sine 0 over cosine 0. The tangent of 0 or 0. Infinity times 0. So this is the type where we will bring it to the form either infinity over infinity by writing 0 as 1 divided by infinity, or 0 over 0 by rewriting infinity as 1 over 0. And then you use L'Hopital rule. So let's do that. This one, I prefer to have tangent up there, so I write limit x tends to infinity, tangent 1 over 3x, and down there we have 1 over 2x. Now we go with 0 over 0. Now we can use L'Hopital rule. Type 0 over 0. L'Hopital rule. Limit x tends to infinity, tangent prime, tangent 1 over 3x prime, 1 over 2x prime. And this one is tangent prime. Tangent prime is secant square. Remember that? Secant, tangent, tangent prime, secant square. So tangent u prime secant square of u, and we will use that. Limit x to infinity, u prime, which is 1 over 3x prime secant square 1 over 3x, 1 over 2x prime, so 1 over 2 still there, 1 over x prime, which is minus 1 over x squared. So I usually do it as 1 over x prime is x power minus 1 prime minus 1 x power minus 2. So that's why I have this, which is 1 over x prime. And you do similarly for this one. Limit x to infinity, 1 over 3 minus 1 over x squared secant square 1 over 3x, 1 over 2 minus 1 over x squared. You see that this one and this one cancel out. Then you have 2 over 3. These factors here, you can bring it out of the limit. Limit x tends to infinity of secant square 1 over 3x. So now secant square, secant is 1 over cosine. This is 2 over 3. Limit x tends to infinity 1 over cosine square of 1 over 3x. X tends to infinity. This one tends to 0. Cosine 0 is 1. So 1 square, 2 over 3 times 1 square, which is 2 over 3. And that's why this limit is 2 over 3. But you know what? This one, next time, you don't need to do this one again. You can just remember the standard limit, tangent of x over x when x tends to 0. So if next time you know this one, remark tangent x divided by x tends to 0, give us 1. So here's why. Tangent 0 over 0, 0 over 0. You can do L'Hopital rule. By L'Hopital rule, this one, we have the limit tangent prime secant square over 1. X still tends to 0. Secant 1 over cosine x over 1. x tends to 0, this one tends to 1. That explains why this one tends to 1. You think of 1 over 3x here as, let me copy that, 1 over 3x here as this value, this x, so this x, 1 over 3x, so x tends to infinity here, this one tends to 0, and you can write down as limit tangent 1 over 3x divided by 1 over 3x, which is exactly this form. X tends to infinity. But now you need 2x, you don't have 3x, and then you need to bring 2 there. So because 2 we still have there, I keep 2 here. Because we divide by 3, I need to multiply 3 back. So that's why this is 2 over 3 multiplies the limit, which is 1. That's why 2 over 3 limit here. This limit is 1. That's why 2 over 3 times 1, 2 over 3. So if you can remember this limit, then you know 2 over 3 without needing to compute all these big derivatives again. I hope you understand that.